Green Rush, Mining the Energy Revolution with Matt Watson.
Hello, welcome to Green Rush, Mining the Energy Revolution. I'm your host, Matt Watson. We're going to be talking about two very small metals markets this week that are very crucial to the hydrogen economy. These are platinum group metal minor metals, Iridium and Ruthenium. We're going to be talking with Furuya Metals and a chief operating officer from their U.S. operations, Mr. Steve Hazelbaker. Steve, welcome to the program.
Matt, thanks for having us. And Furuya Metals is glad to have this opportunity. Thank you.
Thank you so much. So I want to do a little bit of setup, Steve, just to give people some context to the size of these markets.
Sure.
I've got a chart here. This shows the precious metals, the 8 precious metals, gold, silver, and the 6 platinum group metals.
Mm-hmm.
It shows the total revenue if you took all the troy ounces mined and recycled times the average price per troy ounce for the year. You come up with a total available market, if you will, for that basket of metals. And so here we are in 2024. It looks like we're going to approach about $395 billion in total metals value, dominated by gold and silver. If you break off the top little 6 here of the platinum group metals and expand on that, you see this chart on the right. You'll see the platinum group total available market. It's been quite a roller coaster for the PGM basket. And of course, this is the trouble that the miners and many processors are having. Palladium and rhodium were extremely high just a couple of years ago. They've come crashing down back to where they were before, and suddenly the basket has lost a lot of its value. Yeah. Buried in this, I tried to annotate it as best I could, is these tiny little markets of iridium and ruthenium. Iridium's about $1.7 billion a year worth of opportunity, and ruthenium another $1 billion on top of that. So these are two pretty small metals, and yet again, so essential to the hydrogen economy. And just to add some more context for the viewers, for someone who's had a chance to work with much of this precious metals industry, I laid out a slide here with the logos just to illustrate. Everybody I think knows the top 5 major metal processors: Heraeus, Umicore, BASF, Tanaka, which now includes Metalor, and Johnson Matthey. So these are the 5 big boys. They garner about 35% market share of that roughly $400 billion TAM in sales and in the different forms that they transform these precious metals into. And down on the bottom here, I've got a listing of some additional processes, including our Furuya Metals, based in Japan. Their revenue is about $320 million. So, a smaller player, but a crucial player that has a corner, if you will, on this iridium and ruthenium market that we're going to go through. I've also listed a number of recyclers here just to give people some context. So that's what we're talking to today. Each week, I'm going to try to bring different processors to this program. We've had Mitsubishi on, we've had Heraeus on so far. Here's Furuya. In the weeks to follow, I'm going to get Umicore and Tanaka, BASF, and the others to join as well. So we'll give everybody a bit of a flavor for all these different organizations and some of their key product offerings as it relates to the clean energy transition. And so, Steve, finally, I've got you set up. So I've got one of your slides here. Why don't you tell us, who is Furuya Metals? What is Furuya Metals to you, Steve?
Right. Furuya Metals is obviously a PGM manufacturer and recycler, kind of a one-stop shop. 95% of our customers we manufacture with a focus of iridium and ruthenium. Obviously, we provide in-house refining at a high rate, which really benefits our customers to be able to, return that precious metal to them for their future orders and components. I'm glad you said that it's, a minor metal, iridium, ruthenium, but it's very, very crucial, and their characteristics are still being developed around the world for all of these different industries. Furuya had the foresight back in 1952, 1960s to develop and start with iridium, ruthenium, and wanting to become number one in the world in both of those minor metals, which we have. And we continue to educate and develop processes, alloys with that. Furuya's not only Iridium, Ruthenium, we are very good at alloying. We do all of the other PGMs as well. I know we're talking in Iridium and Ruthenium today, but we do service all of the business industries that have PGMs or require PGMs. And we're also small enough. I know we're not in the top 5 and the big guys, but that's good for us because that allows us the flexibility to work with labs, R&D facilities, universities and such. So, we know it's a niche market, but, we try to be the best we can be in those niche markets regarding PGM metals.
Fantastic. Now, I was trying to think of how to frame this. You serve a number of markets, and there's a chart here that shows, a semiconductor. You're dominant in the hard disk drive sector. That's where I first got to know Furuya Metals. As I was a 17-year veteran of the hard disk drive market, buying a lot of ruthenium and platinum alloy targets. So you dominate in that space. But go on, tell us about some of these other markets that you serve.
Sure, yeah. Ruthenium targets was kind of a kickoff. We developed, an IP process that allows us to use, I can say, a sintering process. It's a little bit more technical than that allows us to get almost 100% density, long life ruthenium sputtering targets within that. But we're a big player in iridium crucibles. And in order to do that, you have to be able to machine and forge and do all of those manufacturing processes, which with iridium, which is not easy. Coupled with our ability to refine iridium in all different states and forms, allows us to, manufacture these crucibles, rods, seed holders, pins for crystal growth. We're certainly number 1 in the world in iridium crucibles, various sizes.
Sure. Steve, why iridium crucibles? What role do they play, the crucible itself?
It's basically for a high temperature CZ growth for all different industries, whether it be medical, lasers, tattoo removal is a big kind of a trending point at the moment. All those mistakes that are made in your teens and 20s, technology's caught up and allowed us to fix those mistakes. Parents are happy. But so we do a lot of those, we have our finger in a lot of those technologies regarding crystal growth, LED, sapphires, for that.
Right.
Mm-hmm. Then we move on. We're a big player, obviously, in the sensors. We have OEM contracts. We're an OEM for all of the tool makers, whether it be, TEL. We supply all of the major customers in the semiconductor world, focused on basically type R thermocouples, where they're used in the high temperature multi-point wafer manufacturing for that.
Right.
We're also a big player. If I want to just complete our portfolio from high volume manufacturing, we're a big player in OLED. Everything you see OLED, whether it's phones, laptops, TVs, all, the size of a phone all the way up to a, 88-inch, which probably TV that you probably have, has our material in it. We make the starter emitter material for that. It's an iridium-based material.
It's an iridium chloride. Iridium chloride that's essential to getting the colors to be as bright and poignant as they are. Right?
That's right. So it's an emitter that gets the red, green color schemes that allow OLED to be bright, but not only that, but to be able to take the higher power. For the brightness in those devices.
Right.
All coupled and supported with our refining operations. So everything we make, we can refine, which is a really good service that we can offer to our customers, and they take full advantage of that, of course.
Fantastic. Yeah, and I know the crucibles get recycled. If they're pure iridium, they're not going to get thrown away. And, $5,000 a troy ounce, those are extremely valuable. I do know that the iridium chlorides and some of the OLEDs, now the recovery rate through e-waste is virtually zero on iridium through e-waste. Is that correct?
It's not zero anymore. We've worked on that for the past 3 years with
Oh,
our
yeah.
customers. They are actually sending now all of their waste streams to us, and we have that ability to refine that and get their iridium back into their pool accounts and be able to make, their products, newer products with that.
Oh, that's
So I was
that's
sort of,
fantastic. I didn't realize that. So OLEDs can be recycled. Fantastic.
yeah. So that was a big service that we were working on for 3 years. There's a lot
Right.
of IP involved with obviously the OLED products and their
Right.
display manufacturers. So one of the hurdles was getting over and how do we handle that IP. All of the refining is done in Japan, and we have that 100% now. We can handle
Right.
as much as they can send at the moment.
All right.
It's great.
Fantastic.
We also have a very good relationship with all of the mines in South Africa. So
Mhm.
we actually have an individual sitting on our board from South Africa. So we have a very good open conversation with how much is being mined, how much is above ground, how much iridium or how much PGM materials we're going to use on an annual basis. So we have very good conversations in how to match our refining to meet our customers' needs and give them that stability, which every accountant and every president and CEO and general manager, likes to hear. No one wants to run out of a key component or material.
Right. So let's give our listeners a view to just how much refining that you do.
Mhm.
I think it's astonishing. So, for example, Iridium, you've just expanded. Now you're doing 10 metric tons per year of
Mhm.
Iridium refining. Put that in context, only about 8 to 8.5 tons a year comes out of the ground from
Right.
mining.
Yep.
So your recycle rate is more than what's being mined.
Yeah. And that
Ruthenium,
was
you're doing
that
Ruthenium,
was it.
you're doing 60 metric tons a year, and there's
Yep.
only about 20 to 22 tons a year of ruthenium mined. So a
Right.
huge multiple on ruthenium. So fantastic
No,
job.
yeah, thank you. That's to the benefit of the Furuya mindset of, thinking ahead on
Right.
understanding. Obviously, no one knows what the market's going to do. The market's obviously a big driver.
Right.
In that, it's $5,000 per troy ounce, 465 per troy ounce for ruthenium. About, everyone, it's an important key component to our customers in order to be competitive in their markets and be able to keep their prices at a marketable price. So yeah, we've gone from one building over the past 3 to 4 years. We now have a refining campus. Matt, you're more than welcome to visit us. Give you a full tour, for sure. But we do have the capacity in 10 metric tons, as you said, plus. Also, ruthenium, we've been refining ruthenium for, 10 to 15 years. So all
Right.
of that is now in a Furuya campus, refining campus. So all of our manufacturing is done in Tsukuba,
Right.
Japan. So that's a campus where we have all of our 35 to 40 employees for R&D. We have upwards of, 200, 220 manufacturing employees. We now have a campus which is in Chichira, Japan. So
Mhm.
80 plus employees that are running that. We also have developed last year a R&D building people to have R&D strictly focused on refining low grade, mid grade, and high grade, which we handle all of that now. All of that leads
Okay.
into the metric tons that you mentioned.
Fantastic. And so I want to present my view, my supply
Sure.
and demand models for iridium and ruthenium. And for any market experts that, follow a Johnson Matthey or a BASF or a Metals Focus, SFA Oxford, I'm not sure anybody else's supply and demand will look anything close to this. Like I said, there's, some 700 to 750,000 troy ounces a year that comes out of the ground on ruthenium. And yet I think when you look at your gross demand, you're pushing over 2 million troy ounces a year collectively as an industry. And for Furuya, it's in the form of all these targets that are being recycled at least twice a year. you'll have 20 to 30% utilization by weight and have to recycle the rest, and you'll do that
Mhm.
2 times a year on a very large populations of thousands and thousands of targets. And so I think the gross demands are much higher than people realize. And it's a picture that breaks down that looks like this on the right for ruthenium.
Right.
And iridium, again, I think a pretty good secondary recycle market. I think both these secondary recycle markets are going to be pressed to grow further over time. So I indeed think that Furuya is very well positioned and very much has the iridium and ruthenium markets, has a pretty good corner, if you will, on this market. What am I
Yeah.
reading that wrong, Steve?
No, I don't think so. And I can say this, Matt, that, at one point we were north of 1,000 ruthenium targets a month and recycling that as
Right.
well. Well, I can state that. Same with the, iridium. We're well over 100 iridium crucibles a month, also
Wow.
refining much as well. So, I think you've captured it quite well. But it's also important to think ahead and position yourself and constantly grow, and not be stagnant in some of these legacy products. We're constantly developing new alloys, developing and supporting new markets. So we have a lot of irons in the fire, if you want to say.
And so let's again walk through some of these different markets. So for crucibles, Furuya's view of itself is that you have some 70% global market share on the iridium crucible markets.
Mhm.
You've got some 90% share on these iridium compounds, including for the OLED. Is that right?
That's right. And we expect that to grow over the next 3 to 5 years.
Wow.
We are, as many other, I call them competitors, but I really appreciate their partnerships in developing this, PEM electrolyzer, water electrolyzer market. It's going to take all of us to support that industry. So, that will fall under, chemical compounds as well. So that's a new market, a new plan for Furuya to support that as well. Especially since we have so much iridium and we're processing so much, it's a natural fit.
Right. Fantastic. And then on the ruthenium side, it looks like you feel you've got about a 70% share in ruthenium targets,
Right.
and a lower share in the platinum temperature sensor market, the RTD
Mhm.
markets, but
Sure.
still an admirable market share. That's fantastic.
Yeah.
And then
Yep.
let's jump over now. Let's talk about some of the
Yeah.
emerging hydrogen economy markets. These are more electrochemistry type of situations.
Mhm.
And here you've got iridium and ruthenium compounds that play a crucial role. And we talked about this in last week's episode with Haraeus, mixed metal oxides being one of the key target sets where anodes and cathodes, there's coatings that can go onto these that help accelerate these reactions that you're trying to drive, that play a
Mhm.
crucial role. So why don't you talk a little bit about these markets?
Sure. So, and I'm sure Haraeus is saying the same thing. It's a growing market.
Right.
We're providing those chemical compounds on the anode side, all for the developments of the soaps. Big focus for us is, ammonia and the, other products that are being, quickly manufactured or growing, not quickly, but, growing, and the need in efficiency, right? So, we have a catalog of components to support that, those industries and those markets and those customers. And it's being quite successful at the moment.
Fantastic. What about electrolysis? Give us a little sense of what's going on in the electrolysis world.
Sure. So we, because of our chemical background and our successes in the past with, the iridium chlorides that you had mentioned earlier, we also make ruthenium chlorides, alpha and betas. A lot of testing. It was a natural progression into support that. The ability that Furuya has to calm the scare of the need of iridium and a whole bunch of iridium for the, PEM market or water electrolysis, we can do that. So we have a catalog of production, high volume production at the moment, to support those hundreds and thousands of kgs forecasted. And our products are working quite well, and are actually in electrolyzers today.
Fantastic. And yeah, so there's an awful lot of discussion going on within the precious metals industry about the need to design thrift iridium, that to make the most of what we have,
Mhm.
and to recover and recycle as much as possible. And Furuya, you're keenly aware of this discussion and both the iridium and ruthenium scarcity front. Which, by the way, again, if you go back to last week's episode, I showed some of the outlooks for the mining
Yeah,
outlook for iridium and ruthenium, which are forecast to decline. The mining sector in South Africa is projected to decline over time. So we're going to have to make do with what we have above ground, and so this discussion becomes even that much more exciting and important. But
yeah,
you've talked early on about the need to basically come up with a 10x multiple in design thrifting, if you will, to reduce the
right.
load on these demands.
Yeah,
So walk us through all of this.
sure. So, obviously iridium-based oxides, catalysts are working. With the price of iridium at the moment, we're not ignorant to the need to reduce the uh, iridium. So we've developed other compounds, other catalysts involving, 2 elements, 3 elements. We're even currently working on a non-PGM uh, catalyst,
Mhm.
even though that doesn't sound smart. But, we understand in order to support the world in this industry, we have the ability, we have the technologies to develop other catalysts with a lower iridium percentage ratio. And we're
Right.
doing that. So we have iridium-based, ruthenium-based, and certainly other elements that we're working on. And
Right.
we have great partners that are testing that for us, and a great customer base around the world currently not only testing, but giving us ideas. It's a great communication to share what their needs are, what their forecast is, and what their focus and needs to be. And we try
Right.
to match the catalyst to do that.
Fantastic. Getting a little bit technical and a little bit more geeky than even I normally am. This topic
Okay.
of this ruthenium iridium nano coral is fascinating to me.
Sure.
To me, it's almost like an aerosol product with maximum surface area, which is great for catalyst. You drive
Right.
the catalytic activity, but with the
Sure.
minimum amount of weight. And as opposed to, these ruthenium and iridiums that we're talking about are mostly oxides, which are
Mm.
very difficult to digest and to dissolve, if you will, with
Right.
acids. And so the refining processes are very challenging, especially on the iridium. And
Mhm.
if you were able to do a ruthenium iridium nano coral without an oxide, that provides another source of leverage to garner even better return rates through refining,
Mhm.
while using less in the product itself. So I think this ruthenium nano coral is just a fascinating discussion. And I know you were actually quite open in a previous presentation at the International Precious Metals Institute a few years back, talking about this continuous flow manufacturing technology that you guys have developed. Why don't you go through this a little bit?
Yeah. So we have developed, this mass production technology for nano-alloys. Not to
Right.
be geeky, as you said, but it's basically taking alloys and making them like super, super small, nano levels, and which is going to open up the world um, to all of these, like you said, surface areas, reduced PGMs needed, with the ability to refine these. We've been
Right.
able to get to the 1 nanometer uh, at the current alloy with our technology. I can't get into exact details due to some IP, but again, this slide shows exactly what we're doing on a mass flow basis. So yeah, it's in development. We do have some products that are successful out of this business unit, and we're going to continue on this road because we feel it's next generation, or maybe even the generation after that. It's going to take off.
Right. Now, I don't have a slide for it, but another very fascinating, environmentally friendly topic. People get pissed off when they find out the plastics that we put in our recycle bins, only roughly 10 or 12% get recycled. They have little
Mhm.
triangles with the ones and twos in there. So certain plastics are recyclable, but unfortunately, the lion's share of the plastics that go into recycle bins are what they call a mixed plastic. There's a variety of different types. There's lots of development and discussion that's been going on over the past couple of years using ruthenium as a catalyst to help decompose these carbon-to-carbon bonds in those plastics and ultimately become successful then at recycling the whole lot of plastics. Where does that technology sit right now, Steve, in your view?
Yeah, again, so we obviously know all about that, and we've made some products to support that. We're not sure exactly the scope of someone has to have a business and they have to start kind of from scratch in order to take all of that trash plastics. Obviously around the world it's high volume, but we will have the products to support that on a ruthenium basis. Again, it all stems back to, do you have the ruthenium and can you develop these technologies? I mean, you got to have it, right? That's what it comes down to. And when you have that.
But to me, that's a sleeper category. I mean, when you look at the supply and demand charts, that's not even really on the list. That's a whole new category of potential demand, right? The other new category of demand that I think is emerging is smart glass or electrochromic glass, which are basically two panes of glass with an ITO and in most cases ruthenium as an interlayer, where you can apply a current and create dimming or other features in the smart glass. So plastics recycle and electrochromic glass are really two new categories that, to me, there's only upsides in demand with those markets as that technology evolves. Am I missing something there?
No, I think you're spot on. And again, if you look back at people or companies have been working on that technology with the smart glass, ever since Apple has come around, right? If you look at planes today, right? There was smart glass using iridium that allowed them to dim. It's all about the power and being able to take the voltage and how it's handled. But we do a lot with the glass manufacturers around the world. Not only do we make the materials to support the smart glass, but we also make the platinum, all for the high temperature glass melting, whether it's optical or standard glass. We do have, we make all those components as well. Stirrers and chambers. Yeah.
So I don't have platinum here, obviously, but platinum is one of the main markets is glass manufacturing. That platinum's used at the highest temperature points in glass manufacturing processes, basically just to keep the equipment from melting itself and to maintain operations. So platinum.
Also important there is the purity levels of the platinum and iridiums that are being used in these high temperatures, right? You can't have the contamination. So a few years back, we were actually awarded in London to have processing the highest purity levels of iridium. So that's also a key component in some of those sensitive melts that our customers have.
Fantastic. Okay, Steve. So as we bring this to a conclusion, is there any other points you'd like to bring up about either of these metals and where we're headed?
I just want to say that, or explain that Furuya's in the past 3 years is really focusing on diversity. And one of the biggest diversity areas, obviously we're sitting here, we're a PGM manufacturer and refiner, but we feel that aluminum-scandium targets at all percentages and ratios is a very big project, and we're on mass, we're producing at a high volume and developing constantly, whether it's 4, 6, 18, even up to 50% scandium. So it's another great vision of Furuya to match our technologies, meaning in target manufacturers, we probably make, we're one of the best target manufacturers in developing with that. All of the tool makers use our targets in developing of their tools. So aluminum-scandium is a big avenue at the moment for that.
I'm glad you brought that up. So your recycle and refine capacities, you've got 45 metric tons per year capacity for the scandium, which is one of the 17 rare earth metals, right? So it's one of the very few rare earth metals that does get recycled. But
Yeah.
you're looking at a market where approximately 200 to 220 metric tons a year are mined of scandium, and you're doing 45 a year in recycle. So again, a measure of the scale of your recycle, fantastic. Capturing rare earths, fantastic. You're right. Scandium with aluminum has some very interesting properties. And I know the products that you're making, these sputter targets with aluminum-scandium alloys, it creates basically a piezo electric capable thin layer film that you could sputter onto a substrate for RF filters, for radio frequency filters that are used heavily throughout smartphones and 5G.
That's right. Filters, yeah, RF filters, BAW and SAW. Also, audio is a growing market as well. So these devices are needing more power, and they need stronger piezo materials. And aluminum, like you said, aluminum-scandium is leading the league right now in these areas.
Fantastic. Steve, I just can't thank you enough for your time today. Really appreciate it. I hope people got a sense now, and they will all look up Furuya Metals. You're the sleeper of this community in the precious metals world, in my view. So you have a lot of fantastic attributes and are focused on two of the key metals on the periodical table that we're going to need going forward. So thank you for all your efforts there. So thanks, Steve, very much.
Yeah, we don't mind being the sleeper. We like to do the work. We don't need the grandstanding or anything like this. This is probably the most grandstanding thing that I've done in 5 years. But
and I had to con you into doing this, so I'm glad you did it, Steve.
Ron was worth it. I agree. But also, from Furuya Metal Americas and Furuya Japan, we want to, thank you and all of your efforts, not only reporting the markets, but staying on top of, this huge, very important worldwide traded industries and markets and alloys and elements. So yeah, thank you for all your hard work. We appreciate it. And the education also. I hope the success to you.
Well, thank you so much, Steve. Appreciate it.
Oh, you're the best.
So next week, we're going to shift away from platinum group metals. We're going to start getting into the lithium battery metals. So lithium, cobalt, nickel, and the likes. We're going to start off with a special guest next week from Benchmark Minerals Intelligence, one of my favorite analyst firms in this space. We'll have their COO, Andrew Miller, will join us, and we're going to have a pretty broad-ranging discussion on the battery metals market. So join us next week as we get into that topic. This is Matt Watson with Green Rush, Mining the Energy Revolution. We'll see you again next week. Thank you all. Take care.
Green Rush, Mining the Energy Revolution with Matt Watson.